Good evening, everyone. So, welcome to Career Launcher. My name is Naveen, and today we will continue with our series of Quant CAT 2025. In this series, we are currently doing modern maths. In the last session, if you remember, we solved some very interesting and good questions of permutation and combination from previous year CAT and XAT exam. Today, we will continue with the same, and we will be doing the PNC and probability. We will look at one question or maybe two questions from PNC, and majority of them are going to be from probability. Okay. So without wasting any time, let's look at the first problem of the day. So before we do that, let's look at the concept. So basically, the probability is nothing but a fraction, or you can treat that as a percentage, where the denominator, it denotes all possible cases as per what the question is talking about, while the numerator is only talking about the favorable cases. Now, what do you mean by favorable cases? It means in the word problem, they will tell you a specific scenario that they want to find out. So that's the favorable case. Now, probability of any event, it should always be from 0 and up to 1, where 0 would mean it will never happen, as in it will never take place, while 1 means it will always happen or it will always take place. So this is a good way to understand, if you're not good with probability, as to should you add or should you multiply fractions. The moment you see that you are getting a negative answer or you are getting a fraction more than 1, there is some mistake that you're doing, right? Now, in the case of coins, the probability of appearing a head is given as 1 out of 2. So there are total 2 possibilities. Either there will be a head or there will be a tail. Head is one of those, so that's why it's 1 out of 2. Similarly, the same goes for probability of getting a tail. If we talk about a dice, probability of getting any number, whether it is 1, 2, 3, 4, 5, or 6, it's going to be 1 out of 6. When we talk about playing cards, these are some of the standard types of probability question. The probability of picking any card, it's going to be 1 out of 52. So there are 52 cards overall, out of which you are going to pick 1 card. So it's going to be 1 out of 52. Now, if you're going to pick the next card, there are 2 possibilities. The first card that you pick, did you put it back? If you did, then the second card will be chosen from out of total 52 again. But if you decided not to put the first card back and then you're going to pick the next card out of the remaining cards won't be 52 anymore. It will change to 51. So which one do we have to prefer? Which one do we need? It completely depends on the language of the question, whether there is a replacement going to happen or whether not. Okay. Now, there are certain types of events, okay, that also decides how should we proceed, what should be our thought process when we are solving a problem. So any event, it's either going to be dependent on the other event or it's going to be independent event. Okay. Dependent event. For example, if I am going to race, whether I'm going to come first or whether I'm going to come second, it completely depends on how well I'm going to perform as well as how bad or how well others are going to perform. So whether I'm going to come first or second or third or last, it depends on the other candidates as well, right? So a race is a dependent event. When we talk about independent event, or we say mutually exclusive, it has got nothing to do with what others are doing. For example, if I'm writing an exam and if the exam is of 100 marks, out of those 100 marks, whether I'm going to score 100 marks, whether I'm going to score a 90 or whether I'm going to fail, it has got nothing to do with what others or how much others have practiced or how much they have studied. So this is an independent event. Okay. Now, when we are talking about CAT exam, let's say, is it dependent or is it independent? What score you are going to get? What percentile you are going to get? Is it dependent or independent? It is again independent, right? Though your final score will be transformed into percentile, well, percentile is a relative score. But how many marks you're going to get, what would be your raw score, that is completely an independent event. आपकी मेहनत रंग लाएगी, बाकी कैसा करते हैं खराब करते हैं उससे कोई लेना देना नहीं, right? There are bits of here and there some concepts, some logic involved when it comes to percentile. That if the paper is difficult, how was your preparation? Did you prepare enough difficult problems? Because that will decide how much you are going to score, how many mistakes you are going to make. But overall, writing an exam is always going to be an independent event. Okay. So how do they differ when we are talking about probability? So if you talk about a race, there are two people, let's say A and B. Of course, one of them is going to come first, another is going to come second. Let's say they run three races. Probability of A coming first is one out of the three races, which means if they run three races, A is going to come first in only one of them. So what would be the values in the remaining cells? Can we figure this out? Yes, we can. So out of three races, if A is going to come first in one of them, then B is going to come first in the remaining two. And if A is going to come first in three races, that means in the remaining three races, sorry, out of the total three races, in the remaining two, he's going to come second. So what we see is that the probability sum of coming first or for a particular person, they all add up to give us a 1. Okay. This will be a little bit more complex if there are going to be three people. When we're talking about independent event, so let's say there are two people who are writing the exam A and B. So whether they're going to pass or whether they're going to fail. And if I simply tell you that the probability of A passing the exam, suppose he writes the exam 3 times and he passes only once. Can we fill out all the remaining cells? Well, we can't. We can only fill out the fail of A. So if he's going to pass in one exam out of 3 attempts, he's going to fail in the remaining 2. So only the probability of this event sum is going to be 1. It will be true for B, but what are those numbers? No idea. What would be the sum of A passing and B passing? It's going to be more than 1. It's going to be less than 1. We have no idea. That's the difference how dependent and independent events, they are related. So if it's a dependent event, you may conclude a lot of other things. Independent, not really. Okay, let's start with the first set of the day. In how many ways can 8 directors, the vice chairman and chairman of a firm, be seated at a round table if the chairman has to sit between the vice chairman and a director? So I would like to give you guys 1.5 minutes to go about this. Let me know the correct option in the chat, and then we will start the discussion. Okay. So there is a circular table, and in this circular table, we need to have the chairman. He needs to sit beside a vice chairman and a director. Now, it could be a vice chairman to his right, or it could be vice chairman to his left, right? So what I will do is I'll first of all call in. See, there are total 10 people, right? So let's understand and plot the points. So this is 4 here, and then we need 4 here. So 8 positions. Let's call in the chairman. Chairman will go and sit at any one of the chairs, right? All the chairs are identical initially, right? Whether he sits at the topmost or whether he sits second to the left of the topmost, whether he sits at the bottom, doesn't matter. For him, all the chairs are unique. So if I talk about the chairman, there is only one way. Now, let's say chairman sits here. Now, if I bring in vice chairman and he has to sit beside chairman, he has got two options. Either he will sit to the right of him or he will sit to the left of him. So vice chairman will have two possibilities. Then let's bring in the directors. There are 8 of them. Suppose if vice chairman sits here, then the directors will occupy the remaining 8 places. If vice chairman sits below, the directors will accordingly sit at those places, those remaining 8 places. Since directors, chairman, vice chairman, these all are people, so these are distinct objects. So 8 people can be arranged in 8 factorial ways. So our answer should be the product of all these 3, because chairman has to sit and vice chairman has to sit, and then those 8 directors also they have to sit. So it's going to be 2 into 8 factorial, option B, right? Next problem. Try this, and if you have your answer ready, you can write it in the comment section. Okay. So since we have to calculate the probability of his winning at least one prize means he can win 1, he can win 2, he can win 3, he can win 4, right? So it will be better that out of total cases, if we subtract that case, that he wins none of the prizes, then automatically we will get all those cases where he wins at least 1. Okay, this is not a rule, but actually, instead of calculating 4 possibilities so that he wins only 1 prize, he wins 2 prizes, he wins 3 prizes, and then he wins 4 prizes. We'll have to do 4 cases. Rather than that, we'll prefer if we do only 1. Now, in the case of probability, the total cases or the total probability is always going to be 1. From there, we need to find out where he doesn't win any. So how are we going to do that? So probability of him winning the prize, right? This is going to be 4 out of 16, right? So probability of him not winning the prize, it's going to be those 12 prizes or those 12 lottery tickets where there is no prize at all. What if he selects those 12 lottery tickets? जिधर prize नहीं मिलेगा, right? So 12 by 16 is going to be 3 by 4. Since there are 4 tickets, so the first ticket not getting any prize, it's going to be 3 by 4. Same is going to be the next one. Same is going to be for the third ticket. Same is going to be the fourth ticket, right? So this is going to be 1 minus 81 out of 4 into 4 being 16, 16 into 16 being 256. So we can definitely see that A cannot be our answer. It's going to be 256. So this changes to 256 minus 81 out of 256. 256 minus 81 is 175 out of 256. So B option, right? So probability of him winning all the 4 prizes is, or when he picks a ticket, when he buys a lottery ticket, there are 4 lottery tickets out of 16 where he can win a prize. So that's 4 by 16. Not winning would be 1 minus 4 by 16, or we can say from the remaining 12 lottery tickets where there is no prize in those tickets, out of those 16 total tickets. So that's 3 by 4. So since there are 4 tickets, we will have to continue multiplying them, right? Okay, next one. Try this. So, so we have in a deck of 52 cards, ace is considered as the highest value card. 2 players play a game in which each player picks a card and the player with the higher value card wins. If both the players have the same value card, it will be considered as a tie. If the first player picks a 10, then what is the probability that the other player will not lose the game? So we have got 4 suits, right? The suits being the hearts, and then it's going to be the diamond, and then it's going to be the club, and then it's going to be spades. And each suit they have got cards. The cards are going to be 2, 3, 4, 5, 6, 7, 8, 9, 10. J, Q, K. It's known that ace is the highest value, right? So if you count, there are going to be 13 cards of each suit. Since there are 4 suites, so we will have 13 into 4. That's going to be 52. That's the reason why we have 52 cards overall. Okay, so this is hearts ke sare, this is diamonds, this is going to be spades, and sorry, club, and this is going to be spades. Now, suppose if somebody picks a 4, and when the other guy picks a value which is going to be more than 4, which is 5, 6, 7, 8, 9, and so on, then the second player wins. If the second player also picks a 4, it's a tie. If the second player picks a value less than 4, the second player loses, the first player wins. It's given that the first player has picked a 10. Which 10? I do not know. Let's say he picked this. This is the first player. Now, the second player should not lose the game. Can I say the second player should not pick any out of these many cards? Not losing the game is not necessarily, it means that you have to win the game. There can be a tie as well. So the second player will have these many cards to select from, right? So if you pay attention, this is a block with 5 and 5 columns and 4 rows. So there are 20 cards, out of which the one of the 10s has been picked. So -1. So the second player can pick any of these 19 cards that you see here. and will win the game, right? How many cards are left? When the first player has picked one card out of 52, there are only 51 cards left for the second player, right? So 19 cards out of 51 cards when the second player picks, he wins. Not sorry, he doesn't win, he does not lose. Draw hoga या फिर win होगा. Had the question been the other player will have to win, then in that scenario, the second player would have, I mean, the second player should have picked only these many cards. If you count, these are total 16 of them, 4 into 4, and these are the other three, right? Next one. A small store has 5 units of a new phone model in stock, 2 white, 2 black, and 1 red. 3 customers arrive at the shop to buy a unit each. Each one has a predetermined choice of the color and will not buy a unit of any other color. All the 3 customers are equally likely to have chosen any of the 3 colors. What is the probability that the store will be able to satisfy all the 3 customers? Right? Let's talk about, first of all, total how many cases we are going to have. If the customer comes and picks a phone, it has got nothing to do with which phone he is going to pick, which customer comes in first, total, without looking at any of the conditions given. So if I talk about the first customer, C1, he has 3 options, white, black, or red. So he'll pick any one of those. The second customer will again have the option 3 cases. The third customer will again have 3 options. So there are a total of 27 cases that we can have. Now, out of these 27 cases, we need to find out all those cases which will not exist. As in it's not about first customer wants the phone from this shop. It's not about that. I'm saying if I ask the first customer and the customer has no idea that I ran a shop, if I ask him which color phone does he want, he can tell me either white or black or red. Second customer can also say the same. Third can also say the same. So there are 3 into 3 into 3, 27 cases. Now, out of these 27 cases, if a customer asks, all the 3 customers asks me that they need white colored phones, will I be able to provide that? No, I won't be able to. Right? If the 2 customers ask me about they want black colored phones and one of the customers need a white color, will I be able to provide that? Yes. So we are asked to find out that we will be able to satisfy all the 3 customers. So if we look at the options, it will be better. See, it's going to be something by 27. Something by 27, option A will not make sense, right? 2 by 13 is 18 by 27. 1 by 3 is 9 by 27. 8 by 9 is 24 by 27, right? So it could be only B, C, or D option. Now, out of these, if I look at majority of the options, the numerators are larger than half of the denominator. So that gives us a hint that if we try to calculate all those cases where these customers will be satisfied, it will be more cases, right? So let's find out all those cases where the customers are not going to be satisfied. So out of these 27 cases that we have, we will remove all those cases where the customers won't be satisfied. And if we subtract that, we will get all those cases where customers will be satisfied, isn't it? So, कब satisfy नहीं होगा customer? When the customer is going to ask me 3 white, when the customer is going to ask me 3 black, when the customer is going to ask me 3 red. तीनों को red चाहिए, तीनों को black, तीनों को white, हम नहीं कर सकते, right? So these are 3 cases. The other one is if the customer, 2 customers, they need 2 red and a white, or 2 customers need 2 red and a black, right? So ये हम नहीं कर सकते, right? So this is 2 cases. Any other possibility? No. But now, since the customers are named, so वो C1, C2, C3 को white, 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 black, black, black और red, red, red चाहिए. or we have C1, C2, C3 में C3 needs a white and C1, C2 they need a red, or whether C2 needs a white and C1, C3 needs a red, these all are different cases, right? So if I look into this, इसी के total 3 cases बनेंगे. First customer, second customer, third customer, red, red, white. What if second customer needs a white and the other two red? What if the first customer needs a white and the other two red? So इसके 3 cases होंगे. इसके भी similarly, we will have 3 possibilities. Third customer needs a black, or maybe the second customer only needs a black, or maybe only the first customer needs a black. So we'll have 3 cases. So 3, 3, 3. So this is a total of 9 cases that we won't be able to satisfy. 27 minus 9 is 18 out of 27, which when simplified becomes 2 by 3. So second option is our answer. Right? That question. Next, a group of friends have decided to take a road trip. Whenever they come to a fork in the road मतलब आप रास्ते पे जा रहे हो और उसके बाद फिर वहां से 2 रास्ते निकलते हैं, just like a fork. It's more like this is the fork used in physics experiments, but ठीक है. Typically, this is what we call them. They will toss a fair coin to decide whether to head right or left. If the coin shows heads, they will head right. If the coin shows tails, they will head left, straightforward. If the friends have made 7 decisions, what is the probability that they took exactly 4 lefts? So पहले तो 4 lefts होंगे and obviously 3 rights होंगे. Now whether the first 4 are lefts and the other 3 are rights, or maybe first 3 are left and the second last one is the left and remaining are rights, or maybe both 3 left, 1 right, 1 left, 1 right here. So how many cases are we going to have? So if you pay attention, this is nothing but how many words we can form out of these 7 letters, out of which 4 of those are L's and 3 of those are R's. कितने ऐसे words बना सकते हैं हम? So the number of words we can form, it's going to be 7 factorial divided by 4 factorial and 3 factorial. Okay, this is also known as 7C4. This is also known as 7C3. Same thing. So these are the total number of ways in which left and right is being decided, right? 4 lefts and 3 rights. But it's not only that they're going left and right, it's also about they are tossing the coins. So with every left will happen when they show a tail, right? So 4 बार tail आना चाहिए and 3 बार head आना चाहिए, तब जाके पहला केस बनेगा. So the probability of getting a tail is 1 by 2, getting a probability of another tail is 1 by 2, third tail is 1 by 2, fourth tail is 1 by 2. So this is the probability of getting tails. And then probability of getting heads is 1 by 2, 1 by 2, and 1 by 2 each, right? So this is going to be the first scenario. Second wala bhi yahi hoga, third wala bhi yahi hoga. So basically 7C3 cases will exist where the probability of it happening is going to always stay the same. It's just that second bracket ka 1 by 2 may come in the first or may come in the first bracket. But since the values are same, we won't be able to distinguish between them. Doesn't matter, right? So the answer is going to be 7C3 into 1 by 2 whole to the power 7, right? Let's find out what 7C3 is. This is 7 into 6 into 5 divided by 3 factorial, and 2 to the power 7 is 128. So what we see here is 3 factorial is 6 and this is 6. So we will have 35 out of 128 as the answer, which will be option D here. This is known as Bernoulli's theorem, if anyone is aware of this. So basically, probability of getting a head plus probability of getting a tail, and it has to be tossed 7 times. ये binomial का expansion करना है, wherein I need probability of head to come 4 times. Sorry, probability of head to come 3 times and probability of tail 4 times, along with the coefficient. Coefficient of this is given as 7c3. I hope you are aware of binomial expansion कि a plus b whole to the power 7 में a cube b to the power 4 का coefficient 7c3 होता है. So we have to take care of the entire term here, right? So maybe a little new concept for you, but it's a very, very standard concept that is asked in ZAT and CAT. So practice such type of questions. Okay, it's not, very rare, but it's not very common as well. But yes, it's common. Well, your roadmap to QA success. The next session will happen on 15th of April at 8:30 p.m. So the coming Tuesday. Mr. Shashank Gohe is going to take arithmetic. This is session 2 of percentage 1. It will be live on YouTube, so do not miss out on this session. Please watch it. Okay. If you have any queries, if you want to ask me any question, please go ahead. I'll wait for a minute and a half. If no, then later on, if you're watching this, you can ask the query in the comment section below. I'll respond. Let's see if anyone has any doubt. Okay, none so far. So feel free to get in touch with me. Thank you, everyone. Thank you for watching. Please make sure that you subscribe to the channel if you haven't yet. Like the video and share it with your friends. Take care. Thank you. Good night.